project is an EDF project, and EDF is an electric ducted fan, and this right here is an example of one. This is a 6-bladed EDF with a 35-degree pitch. So the correlation between the pitch and the amount of blades on an EDF determines how much thrust.
Alright, 4-blade EDF, trial number 1. We're testing for thrust. And Mike, chat, go up to 50. Alright, so I copy 50. Alright, get ready to turn it to 100.
Alright.
You gotta flick it, Matthew.
I'll flick it.
Oh, there we go. 100.
It is now moving to the left.
A little more, Mike.
We're at 100.
Okay, I copy on the 100.
7 grams.
7 grams thrust. Motor power is at 99.9.
3.5.
The motor we have chosen is a 7.2 volt FFRC brushed high torque motor. This motor is used for the RC buggies, which is good for our experiment because the motor gives us good torque at 19,000 RPM. We are using a shaft adapter from a 3.76mm shaft to a 3.76mm screw. Also, attached to the motor is a duct which allows all of the thrust to be directed downward. As you can see here, it'll filter through this duct and will go downward, so then all the force, all the thrust will go down. The motor under no load consumes about 2.5 amps.
For this test, we'll be seeing how much thrust each EDF produces. Each EDF, as said by Mike, will be varying the number of blades. To measure this thrust, we'll be using a scale that measures grams. The motor and EDF assembly will be placed on the scale and the scale will be zeroed. The motor will then be turned at 100% power and we will take the absolute value of the scale's measurement.
The motor will be controlled and powered using a number of electrical components. An Arduino and potentiometer will control the speed of the motor. A 12-volt relay will control the main power going into the motor. A schematic of this test circuit can be found in the description below. Keep in mind this circuit will only work with a brushed motor.
Initial experiment, we tested the EDF without the duct, and we noticed it had a 5-gram average and a 6-gram peak. And then our next experiment, we tested it with the duct, and we noticed a significant increase in our thrust with an around 8-gram peak and a 7-gram average. So we can take note that with the duct, our EDF improves drastically. And for our test day sheet, we noticed the 4-blade EDF did not perform as well compared to the 9-blade and 12-blade EDF, which the 9 and 12-blade EDF both averaged around an 8-gram peak and a 7-gram average, while the 4-blade EDF averaged around a 3-gram average and a 5-gram peak. The EDF that performed the best was the 6-blade EDF with a peak of 42 grams and an average of 30 grams, which clearly defeats the other EDF. So to conclude our study, the 6-blade EDF at a 35 pitch performed the best. Dude, this blooper section is going to be longer than the actual video.